Hello and welcome to this tutorial. Today I will be going over the US cold form steel beam calculator. First, let's create the calculator together. You can find it under the US beams, and today we're just going to go over the generic beam. Before going into further detail, let's just take a look at some of the references and assumptions for this calculator. We use the AISI S100-16 2020, and for some of the assumptions here, we do use the direct strength method for local and distortional buckling, and also for built-up sections, we are considering the conservative approach, which I will go on further detail further on in the video. First, we're going to start with the key properties. As you can see, this is pretty similar to any of our other beam calculators, but for simplicity, I'm just going to go over the inputs. The first thing that you're going to see is our designation. If you click on select, you can see that these are all of our CFS members. You can filter them out by section type, and also maximum total depth and maximum flange width, and at the end, maximum design thickness. If you're not familiar with our platform, I'm just going to quickly go over what these mean. These are what we call traffic light checks. As you can see here, basically the red X or the red utilizations mean that your member here is not passing in deflection and also moment, but it is passing at your shear and your combined moment and shear. The 59% here means that it's at 55% utilization, and basically 789% means that it's, 789% means that it's over the 100% utilization by a lot. After you've selected your member, now you can select your section type. Remember I was talking about the box beams? This is where you can select it. So I have a choice of back-to-back beams. As you can see here, my section changes, and also my box beam. Again, we see this note saying that the built-up sections are calculated using conservative approach, and all the intermediate calculations are only for one single member, and for calculating capacity, it's just multiplied by the number of sections. So basically here, it's going to be multiplied by the capacity of this one section is going to be multiplied by 2 if you select a back-to-back or a box beam. After that, after you're done with your section properties, you can select the beam plan length here. You can change this number to anything you'd like. Just a reminder, the beam plan length is the distance from the start to any to the end, including any intermediate support. So this is basically the full length of your beam. After that, you're going to enter the lateral and torsional on brace and effective lengths. So if you click on the description here, we have more information on what this basically is. You can go to the AISI S100-16, but for a simple description here, the top flange lateral bracing really means that this is the distance between your lateral bracing on your top flange, and this is the same thing on your bottom flange, and this is the length between your torsional braces. Once you're done with those, you can position your supports. Whatever your supports, what position you put, you can also see it in this diagram here. So I'm just going to change my pins. I'm actually going to change this to a roller. Then I'm going to change this to, let's say, 4. And as you can see, this moved, and now I have a cantilever. I'm going to just increase this a little bit. And now it's in the middle. Okay, so once you're done, you can also select web holes. You can have circular or non-circular, and here you can select their dimensions. After you're done with that, you can select your loads. Again, our loads, the loads here are basically very similar to any of our beam calculators. But again, I'm going to go over it real quickly. You can add distributed loads, line loads, and point and moment loads. You can see the description of what these are inside in this information section here. But basically, you can edit the loads, and here you've got your load type. Just going to change this back to dead loads, and you can change your magnitude. And remember that the magnitude is in PSF. Because this is in PSF, you're going to get a trib area, a trib width that you can change, and also you're going to get a start and end location. So let's say I don't want this to be at L, I want this to be at L/2. Now you can see my floor load has changed, is now in the middle. It ends in the middle. You can also select the line load. Remember that the load magnitudes are in PLF. And let's say I'm just going to add a start of 1 and the end of 5. Dead load, close this. I'll have to give it a start location and an end location. As you can see, now I've created a triangular line load. You can also enable self-weights, and if you'd like, or disable it. You can also use reduce companion live load if it's applicable to you. You will basically get a 50% reduction in live loads if it's allowed. After you're done with your loads, now the last part is for you to decide the design criteria. Design criteria, most of these inputs are coming directly from your project defaults. And if I click on these, you can see that the project default pops up. If I go to my project default, scroll down a little bit, this is exactly the design criteria. Most of the information is coming from this table. So you can basically change these, and you can see that once you change these, your values in your beam calculators will change. Oop. You can disconnect it from the project default if you just give this a value. Let's say if I do 500, but this is a good feature because all your beams, if you create any beam calculator, all your beams are going to have these specific limits. You can also see that we are using the International Building Code IBC 2021. You can change this inside the project defaults if you go in the building code, and you can change the year or also the code that you'd like. This will change your load combinations. And one last thing is that you can also change the beam, the incline of your beam. You can change this to a simple slope. And this is, as you can see here, we've changed this to a sloped beam. You can change the slope here in the incline pitch. And you can also change it to a hip corner slope. And the one last thing is this one here. You can also allow an elastic reserve capacity of the beam. So this basically just allows some localized yielding within the cross section. Usually this is a yes, but if for some situations like connections, you might not be able to use this. After you're done with your inputs, we're going to go up and take a look at our summary. Now you're basically done with the inputs of the calculator. You can see that we give you the positive and negative moment demand, as well as the positive moment capacity and negative moment capacity. If you open this, as I mentioned here, for boxed and back-to-back beams, we're literally just multiplying this value here by 2. As you can see, my moment capacity is way above, and it's saying that it's not enough moment capacity. Yes, I'm just going to delete some of the rows here of loads just to decrease my loads, and now you can see that it is passing. We also calculate the shear demand and shear capacity at the holds, and whip crippling and web crippling capacity, and our deflection. If you want more information about where these numbers are coming from in the summary, you can scroll down, and these are all the information. You can get all that information in here. We have our load combination based on the code that you selected. We've also got the unfactored load analysis. We do yielding and global buckling, local buckling, distortional buckling, and web crippling capacity, combined bending and bending and shear, and combined bending and web crippling. And at the end, we do per span deflection analysis. If you'd like to see what load combinations created these conditions, you can go over to the detailed section and you can take a look at your moment. This is the governing load combination for your positive moment. And this basically happens, you can see that in all, for all of your capacities. And lastly, if you scroll down, you can look at the graphs by load case. You can change this to whichever load combination you'd like. Just remember that the black line here is showing your worst case, and your green line is showing the load combination that you have selected here. And that's it for the cold form steel beam calculator. Please let me know if you have any further questions. Have a great day. Bye-bye.